Welcome to second day of 5-day Spring Framework Programming Code Camp from JPassion.com. The topics we are going to cover today are Maven Basics, and we are going to skip topic number 6, and we are going to mostly focus on Spring MVC. So it's my hope that I can finish at least these three topics: MVC Basics 1, MVC Basics 2, and MVC Form Handling. I would say these three topics are probably the most important topics during this 5-day code camp. Okay, so hopefully you guys actually have a lot of learning to do. All right, so let's move on with the Maven. So as I said before, most Spring Framework projects are in the form of Maven, and having reasonably good understanding on Maven is important. I assume some of you already have some knowledge on Maven, so this is basically for people who are new to Maven. So if you are familiar with the Maven, you can skip this session if you want to. Okay. All right, so let's move on with the Maven basics. So these are the setup topics we are going to learn. So we're going to learn what Maven is and Maven installation, and we are going to create very simple Hello World Maven project at the command line, and we are going to learn the concept of POM, Project Object Model, and we'll learn the concept of archetype and plugins and goals, life cycles and phases, and concept of repositories and dependency management, and then we are going to see Maven web project structure, and then finally we are going to compare Maven and Ant. Okay, so a lot to cover. We have another session on Maven, Maven Advanced. So if you go to Java Programming Tools course, Maven Basics 1, which we are covering right now, and Maven Basics 2, actually in that course. So if you want to learn more on Maven, you can also take a look at the Maven Advanced topic. Okay, so in that topic, multi-module project and grouping dependencies and POM inheritance and concept of profiles, more advanced dependency management and site generation. These kind of advanced topics are covered in Maven Advanced topic. So here we are not going to actually cover these advanced topics. Okay, so what is Maven? You can think of Maven as a software project management tool, which includes the build facility. Okay, so Ant is mainly a build tool, and Maven is more than a build tool. In fact, this is Maven is software management, project management tool. So a lot more comprehensive features. It is based on project object model, and it is captured in an XML file called a pom.xml file. So every Maven project has a pom.xml file which maintains everything about that project. That should include the build information, reporting information, and documentation information, developer information, any information that is relevant for maintaining that project is captured in pom.xml file. This POM can be inherited between parent and child projects. So it is in fact following the object model, and that's the reason that I think it is named as project object model based. It is based on convention over configuration principle. So compared to Ant, in Ant you have to specify every single the detail. Otherwise, it's not going to work. In Maven, a lot of convention is assumed. So as a developer, only thing you have to specify is something that is deviating from the convention. So minimum configuration is needed. Another difference from Ant is that in Maven, you specify what needs to be done rather than how it needs to be done. So Ant is more or less on how it needs to be done oriented, while Maven, you specify what you want to be done, and then Maven figures things out. It is also based on plugin architecture, and it has a very vibrant Maven ecosystem. So lots of plugins available in Maven ecosystem, and that certainly actually gives a lot of advantage using Maven. So these are the set of Maven's objectives. So the issues that we have actually experienced as a developer or a system administrator or the release engineer, these are the issues, and these issues are supposed to be handled by Maven. So the first issue is, why do we have to waste so much time in maintaining a build? In every organization, software organization, it wasn't uncommon to have a release engineer whose dedicated job is actually to handle the build process of software. It's because of the build process has been pretty complicated and complex. So it doesn't really have to be that way. So Maven is trying to actually simplify that build process. The second issue is why each developer has to maintain his or her own build environment. The reason is because every software project has its own directory structure, for example, and each developer sometimes has to maintain his, her, or own development structure and the development tools and everything like that, things like that. So Maven actually simplifies that process as well. So it provides a uniform build system so that every developer should actually use a common build system. Next issue is, why do you have to do extra work to get project information? As I said before, Maven is more than a build tool. So every other meta information about the project should be actually also should be maintained somewhere, and so Maven actually simplifies maintaining project information. Best practices. So as a developer, we actually kind of learn what would be the best practices for building and deploying and writing, software code. And Maven is trying to capture those best practices. For example, what is the best directory structure for building Spring application? What is the best directory structure for writing Hibernate application? So those kind of best practices are captured in Maven, and so when you create, for example, Spring project, it knows exactly what is the right directory structure for a particular Maven project. And allowing transparent migration to new features. So tool vendors or plugin vendors can actually continue to their innovation, while without affecting the backward compatibility. So every plugin should have a version, and all you have to do in your pom.xml file is to specify the version. So a particular version number should actually indicate what is the version I want to use. So the plugin vendors could actually continue to evolve their plugins with the different version numbers. As I said before, Maven is designed to provide a quality project information. So project information is include log document, change log document created directly from the source control, and cross-references sources, mailing list, dependency list, unit test reports, and many more. And all these things could be actually provided in the form of the plugins. And if you want to actually capture some project information in your custom way, and you can certainly build your own plugin to do that, to do that kind of custom project information gathering. So these are a little bit of repeat Maven features. So simple project setup that follows best practices. Get a new project or module started in seconds. So if you can actually build a Spring project, you can actually build a Spring project from archetype that is available from Maven, and then you could actually have a working Spring project in seconds. Consistent usage across all projects means no ramp-up time for new developers coming into a project. Because every project is using same directory structure and same way of actually building application, there is no learning curve for new developers coming into the project. Superior dependency management, including automatic updating and transitive dependencies. So it has a very sophisticated dependency management, including transitive dependencies. So we're going to actually talk about this one later on. Able to easily work with a multiple project at the same time. So it has, for complex project, you can actually divide a project into modules, and then you can have a parent project that actually contains all those child projects. So large and growing repository of libraries and metadata to use out of the box. So Maven has a repository on the net, and a lot of pretty much all the popular open source projects maintain their libraries in that Maven central repository, and so you should be able to actually get those libraries out of the box without doing anything. Okay, so it knows where to go. So Maven knows where to go to get those libraries. It's extensible with the ability to easily write plugins in Java and other scripting languages. Again, you can actually write your own plugins to do whatever you want. Instant access to new features with little or no extra configuration. So again, a lot of features are available in the form of the plugins. Okay, so let's move on to Maven installation. So Maven installation is pretty simple. Yesterday we were actually using STS on Eclipse, which actually has a plugin built in, which actually contains a Maven built in, so we don't have to install it ourselves. So since we are going to actually run Maven command at the command line, we are going to download it and install it. Okay, so you go to this website and you're going to download it and unzip it. And then you're going to have a bin directory of that downloaded, bin directory of the Maven in your path, and then you should be able to actually call mvn command. Okay, you have to make sure that Java home environment variable is set to JDK, because Maven command actually uses Java home environment variable. Okay, so in Linux or Mac, this is the way that you can actually set the path, and on Windows this is the way you can set the path at the command line. Of course, you can actually set it in the control panel so that this is automatically done every time you're actually running the command. Okay, so we are going to create a very simple Hello World Maven project. So this is the command that you are going to use: Maven and archetype :generate, and basically it's asking Maven to generate a simple Maven project, and then you will be prompted to provide the following information: archetype and group ID, artifact ID, and version, and what is the package structure you want to actually use. Okay, and we're going to actually learn the concept of these things in detail in the following slide. So once you provide this information, it will create the project directory structure with a name of, under the directory name of this artifact ID. Okay, so it will use artifact ID as directory. It will create that directory, and underneath it will create the directory structure for that particular archetype. Archetype is like a project template. Okay, it will also create pom.xml file. Okay. So after that project is created, this is what you are going to see. So it creates, in fact, the src directory and test directory. So test is important, so it will create both the source file directory as well as test file directory. And you can see there is a pom.xml file that gets created as well. So this is the directory that gets created. So name of the project is the same as archetype ID, artifact ID that you specify, and it creates a main src main Java, and this is the package that you specify. And again, at the compatible at the same level, it does have a main test/Java directory that should have the same package as this. Alright, so we are going to do our first exercise, exercise 1. Here we are going to create the simple Maven project. Okay, so let's take a look at the lab documentation. Okay, so we are going to do exercise 1. First of all, exercise 0 is you want to download and unzip it. So download Maven from this directory, and you can just click download here, and then you can download the zip file, okay, binary zip file, and you can choose any website that hosts the file, and then you're going to unzip it using any unzip utility of your choice. I'm using jar-xvf, and then it will create Apache Maven 3.0 or whatever version. And then you want to set you want to make sure Java home environment variable has been set, just make sure it has been set. It's highly likely that you already have set, so you can take a look, echo and Java home, and make sure it has been set with the JDK of your system. And then you're going to add the bin directory of Maven, the installation, to your path. Okay, and then when you type Maven -- version, then you're going to see the version. Okay, so let me actually show you. In my case, I probably have done all these things. So Maven -- version. Okay, and it has the version 3.0.3. So Maven command is working in my system, and you can take a look at the help command, Maven -help. And again, if you are actually running Maven command behind a firewall or proxy server, then you have to actually set settings.xml file to have this proxy information. Okay, so if you are directly connected to the net, then you don't have to set this proxy. All right, so let's do exercise 1, 2, 3. So here we are going to create a Maven project. So you are going to type Maven. So go to, I'm going to create my Maven project. So I'm going to my Maven project. So this is the directory that I'm going to create my Maven project. So you are going to type Maven archetype : generate. Okay. Then it's going to actually list all the projects that you can create. In fact, there are a lot. So right now you can choose from 885 choices. Okay. And so choose a number. So basically this is the number that you want to just accept it. Depending on the version of Maven, you might actually have a different number. So this is the default project that we want to accept. So just press enter. Okay, and then you are going to here this number is the most basic default project. Okay, so default Java project. Okay. And here we are going to choose the version number. So we're going to choose 1 and press enter. And you can see it's downloading things. And now define your property group ID. Group ID, you can think of it as the grouping of your project. So what you want to do is, you might want to actually use some kind of a domain name structure. Like I'm going to use com JPassion .examples. Something like this. Okay. All right. And artifact ID is the name of your project. Okay. So here I'm going to use hello world -app. Okay. And the version, I'm going to use this version. And the package, I'm going to use the same package as the group ID, but you can actually give a different package structure if you want to. As a default, it is set as a group ID. So I'm going to just enter. Okay, and it just wants to make sure that these are the information that I want to actually accept. So I'm going to say Y. Okay, oops. It says, let me see why it failed. Failed to execute goal, Apache generate on project, error, pom.xml file. Oh, maybe I should just press enter. Okay, so let me just try again. Okay, just accept the number that is given to you. So this is the simplest possible project. And group ID, again, com JPassion and examples. And artifact ID is hello world app, like this. And property version, I'm gonna just accept it. And package, I'm gonna accept it. And here enter. Oh, why is actually keep failing? using the following parameters for creating project old archetype. Okay, and total time. Oh, directory. In this case, directory is already exists, so I'm gonna actually try some. I'm gonna actually try to give different name. All right. Select one. JPassion dot examples, and artifact ID is again hello world app 3. Different directory name. And version this one, and the package like this one, and here I'm not really happy about this, so I keep failing on this. Here reading pom.xml file to see the full stack. Okay, so let's actually try. Let's see. Hello world. Okay, now that worked. So yeah, so I'm not sure why that actually failed. Okay, so anyway, so it looks like you should be able to actually do this exercise fine. So now, if I take a look at the structure, I can see I tried the hello world F5, right? Okay, so I'm going to actually take a look at the hello world F5 directory structure, and you can see it creates the SRC directory with the main and test with the packaging that I specified and the pom.xml file. Okay. All right. So that is exercise 1. So study the pom.xml file. So you can see pom.xml file contains the group ID, artifact ID, packaging, and version, and then one single dependency, which is a JUnit. Okay. So if you take a look at the uh, this is a dependency that was just generated automatically. All right, now that is pretty much what I ask you to do for the next, let's say, few minutes. Okay, and then we're going to move on to the next. Okay, all right. So I'm going to give you about the 3 or 4 minutes to do this exercise. All right, so let's take a look at the pom.xml file in a bit more detail. So pom.xml file contains everything about the project. It includes information about the type of the project name, project identity. Sometimes project identity is called coordinates, and this is important information that we are going to learn in a bit more detail in the following slide. What are the build customization? For example, if you want to use a JDK 1.7 instead of the default JDK version, you can customize it. What are the dependencies? When you're building your application, what are the job files that it needs? Those are in the form of dependencies. And what plugins are used? So everything is included in pom.xml file. So these are mostly build related information, but you can also include the project information such as the names of the developers and things like that. So this is the simplest pom.xml file that we just created from our Hello World application. So you can see this is the identification of this particular the application. Okay, so combination of group ID, artifact ID, and version. Those 3 items in combination identify this particular application. That's the identity, okay, of this project. And sometimes that is called the coordinate. Okay, and then it has a name, and it has a URL, and then it has a dependencies. So it does have a single dependency of just the JUnit. Okay, so every dependency itself is a project, so it does have its own identification. Again, group ID, artifact ID, and version. Okay, and we're going to talk about the concept of scope later on. So project identity or artifact identity or coordinate. So this is very important concept. So everything, I said everything in Maven world is a project, and every project has a unique identity. Okay, and this identity is specified by project coordinate. So the reason it is called a coordinate is because you can consider it as an address in a specific point in space. So it uniquely identifies in all repositories. Okay, whether that repository is a remote repository or local repositories. And dependencies and parent references are described with their own project coordinate. Okay, so dependency is a project. So project has to have identity. So if you see an example here, this particular dependency has its own identity in the form of group ID, artifact ID, and version. Okay, so created with the following combination. So again, group ID, artifact ID, and version. So a combination of those three identify a particular project. So this is a little bit of repeat. So group ID typically represent an organization. So this is a grouping of your project. Okay, so group ID is, for example, like a com.jpassion.examples.marketing or com.jpassion. The sales or something like that. So as long as you actually give, this is a name of your grouping of your projects. So convention is to use a reverse domain name like a com.jpassion.examples. Artifact ID is a unique identifier on the group ID. So within the group, there could be multiple artifacts, okay? And each artifact should have its own ID, and that is specified through artifact ID. And version, each artifact should have a different version, right? Could have a multiple versions, so the version identify what particular version under that artifact ID. So the combination of these three things identify a particular project. Okay, concept of archetype. So archetype is, you can think of as a project template, okay? So you can think of it as original model or type after which other similar things can be pattern or prototype. So you can think of it as a project template, okay? Yesterday when we create a Spring MVC application from a template project from STS, it's exactly the same concept, okay? So it captures the best practices, which includes directory structure, meaning what is a directory structure that, what is the best directory structure for Spring MVC application. And it should actually contain all the dependencies built in, okay? And whatever plugins it needs also need to be actually included. So when you create a Spring MVC archetype Maven project, it should have it should have the directory structure that captures the best practices, and you should actually specify all the right dependencies in the pom.xml file, and it should also include all the plugins that it needs. And you might in fact actually create a lot of files that are typical for the Spring MVC application. Okay, so it really actually helps you to get started, for any kind of a software project. So there are many different kinds of archetype already provided by Maven community. So you can build a simple Java application. So the one that we actually chose as a default, right? That is actually simple Java application. And you can build a Spring application, Hibernate application, JSF application, Java E6 application, and many, many more. So as you have seen, we have like a close to 85 different project templates. In other words, archetype that we can choose. Okay. All right. So user-specific configuration and local repository. So let's talk about these things. So user-specific configuration can be specified in the home directory and .m2 and settings.xml file. So this is a file that you can specify, for example, like a proxy information. Okay. It contains user-specific configuration for authentication, repositories, and other information to customize the behavior of Maven. And one of the information you can include is the proxy information. Now, another directory on the .m2 is repository. So this is a local Maven repository. So anything that you created, any artifact you have created will be saved, will be maintained in this local repository. Okay, and any dependencies that you have downloaded from the network will be also maintained in this local repository. So next time your job file, particular job file is needed, Maven is going to take a look at your local repository first and see if it is there. And if it is there, then it's going to use it. Okay, so it doesn't have to download it again. If it cannot find it, then it will go to the network and download it and then save it again in the local repository. Okay, so it stores the locally generated artifacts. So when you call Maven install, basically what it does is that it creates a job file and WAV file, and then it will save in your local repository. Okay, so that it could be used by other projects. All right, so if you take a look at .m2 repository, so why don't you actually go to that directory in your system. Since you have built in some Maven project, you should actually see that. So go to your home directory. So I'm going to actually go to home, and which is a user Sang, and then you should actually see .m2. Okay, so I can go to .m2, right? And here, settings.xml file is not created as a default. So if you want to actually create a settings.xml file, then you can actually manually create one. Okay, and now you can see repository directory. So if you actually go to repository, okay, you can see these are the artifacts that I have actually installed in my local repository. So you can see I have already built some application that requires this Apache Commons, right? So these artifacts are downloaded and installed the local repository. So next time these Commons job files are needed, my Maven system is going to actually take a look at this my local repository first, okay? And we'll actually get it from here instead of from the network. Okay, so this is the local repository. Now, let's talk about the Maven lifecycle and phases. Okay, Maven is based on the concept of build lifecycle. Okay, so what it means is that the process of building and distributing a particular artifact or project is cleanly defined. Okay, so for a developer building a project, the only thing that the developer needs to learn is a small set of commands to build any Maven project, and like a Maven install, Maven package, and things like that. Okay, and then so there are three different built-in build cycles. Default, this is typically what we are going to use. Clean and site. Okay. So this is again typically what we are using. So let's take a look at the the default build cycle. Now each of this life cycle has what is called the phases. Okay, so each of this build life cycle is defined by a different list of build phases, and a build phase represents a stage in a life cycle. So let's see an example of those build phases of the default life cycle. So this is the build phases of a default life cycle. Okay, as a validate the project, and all necessary information is available. Compile is the next phase, and test is the next phase, and package. So when you say Maven package, it will create a jar file or WAV file. Okay, and integration test is actually process and deploy the package if necessary into an environment where integration test can be run. And verify runs any checks to verify the package is valid and meets the quality criteria. And then install. Install, the difference between package and install is that install is going to create a package first, and then it will install the package in the local repository in this directory. Okay, and then deploy is actually doing a deployment. Okay, now these are done in sequence. So when you say Maven install, it will do everything up to that point. When you say Maven compile, it will do validate and deploy and compile. When you say package, then it will do Maven validate, Maven compile, Maven test, and then it will create a package. Okay. So build lifecycle basics. So these build phases are executed sequentially to complete the lifecycle. So as I said before, when you say Maven compile, all phases up to compile phase will be executed in sequence first. Maven install, same thing. All the sequences up to that point. So if you see Maven install, if you call Maven install, all this will be done first. So if compile has not been done yet, then it will do compile, it will do the test, then it will create a package, and then do the integration test and verify, and then it will install it. Okay. Maven integration test, again, all phases up to integration test will be done first. Clean lifecycle phases is, typically we are using clean. It removes all files generated by the previous build. Okay, so you can actually use multiple lifecycles. So typically, what you can do is, for example, if you go to Maven, so you can go to hello xx, you can say Maven and the clean phase. And then you can say the Maven package, something like this, okay, or install. Okay, so this is from the clean lifecycle, and this is from the default lifecycle. Okay, so typically, you are going to do Maven install, something like this, and we're just using a default lifecycles install phase. Okay. Okay, now phases and goals. So this lifecycle is made of multiple phases, right? Install, package, test, compile, and things like that. Each phase is also made up with goals. Okay, so the plugin goals are attached to lifecycle phase. So we're gonna actually talk about the concept of plugin, and plugin goals are attached to lifecycle phase. So as Maven moves through the phases in lifecycle, it will execute goals attached to each particular phase. So you can think of each phase may have 0 or more goals of various plugins. Okay, so we'll see examples of this in a few in the following slide, in exercise 4 and 6. So let's take a look at the exercise 4 and 6. Okay, so here we are going to actually perform Maven compile. So we are performing compile phase of the default build cycle. Okay, and this compile phase is going to perform the multiple goals of a particular plugin. Okay, so as you can see, it is using these plugins, and this is a goals, and then it's using compiler plugins. This is a goal. Okay, so in a phase, basically what it does is that it's going to use a set of plugins to perform its task, and each plugin is made of goals. Okay, it can perform certain set of goals, and here when you say Maven compile, it is going to execute this resource goal of this plugin and compile goal of this plugin. Okay, so that's what should happen. So if I say compile, okay, you can see it's actually using so because it's, so this is the one. Okay, so resource plugins, resources, plugin, and same plugins and compile goal. Okay, so that is the set of goals. Okay, if you say package, it does a lot more than that. So it does use first of all, it's going to do compile first, right? And then it's using other the goals of different plugins. So we have a resources plugins, and this is a test resources goal. And so you can see it's actually doing a testing phase as well when you say package, because testing is before package, right? Okay, and you can see it does in fact do the testing, and then it creates a jar file. Okay, so when you say package, it creates a jar file. So jar file is everything that gets created is going to be on the targets directory of your project. So this target is the directory that contains all the generated files. Okay, so in this case, the jar file is generated. Okay, all right. So you can take a look at the target directory, and the jar file has been created. Okay, like this, and then if you do install, in addition to creating a jar file, it will also install that file. It's going to install this jar file into your repository. Okay, so this is a repository where the jar file is installed. Okay, so some another project might actually use this one as a dependency, and then Maven is going to take a look at this local repository to get this jar file. Okay, so you can take a look at the repository to make sure that jar file is in fact installed, and then you can run the application. Okay, and it should actually display hello world. So you can specify this is a class path, and this is a jar file, okay? And it should actually oh, I'm sorry, this one has to be you have to specify the complete. Yes, you have to actually specify the whole thing in a single line. Okay, you have to still have to give the class that contains a main class. Okay, so that should actually return hello world. Okay, all right. So I'm gonna give you guys another 10 or 12 minutes to try this. Okay. Okay, so the next topic is Maven repositories. Okay. So what is a repository? It maintains all the projects. Typically, it will maintain plugins and dependencies, artifacts. So these are all. I mean, when I say artifacts, I'm talking about project, and there are many different types of projects. One of them is plugins. Okay, and dependencies are typically jar files, right? So plugins and artifacts are retrieved from the remote repository as needed basis. And the default remote repositories maintain all public plugins and artifacts. That's the reason you don't have to specify where your Maven is supposed to go and get, because the Maven command knows where to go. Okay, so that is what is called the Maven Central. So this is actually maintained by Maven community, and this is where all the open source and important the plugins and artifacts are maintained. Okay. In fact, if you go over here, you should be able to actually, it's actually directed. Okay, so this is a central repository. You can see, the list of all the artifacts that are being maintained. Okay. And custom repositories can be set up to maintain non-public plugins and artifacts. So this is something I just mentioned a few minutes ago. A default remote repositories can be replaced or augmented with references to custom repositories. So this is very typical. Reasonably good size organization, they might have their own custom repositories. They do that because of a few reasons. One reason is, of course, the privacy reason, and the second reason is for performance reason as well. Okay, so going to the public repository takes a long time. So if you are building a very large application, the build time could be actually reduced by using the local repository instead of, the custom repository instead of going to public repository. And of course, the third reason is that the public repository does not actually maintain your artifacts anyway, right? Okay. So repository structure, each artifact is maintained in a directory structure that matches the project coordinates. So it should be in a structure like a group ID directory and artifact ID directory and version directory, and then it's going to have artifact and version and packaging. Okay. So suppose this is the artifact ID. Okay, I'm sorry. This is the what you're looking for, and then it's going to be in the form of the org directory, Apache directory, commons, email, and /1.1, and then it's going to be jar file or WAR file. Okay, so this is the name of the artifact ID dash version, and then the packaging. Okay, so if you are actually looking for JUnit, which is a group ID, and this is the artifact ID, and this is the version number, then it's going to look for, Maven is going to look for in a repository in this directory structure. It will use JUnit as the initial directory structure, and then this is the artifact ID and the version number. Then it will try to find a jar file with this format. Okay, so Maven can easily locate the artifact in any repository, because every repository should actually maintain the artifacts in this directory structure. Okay, so again, if you actually go to this remote repository, you can see I can just click any place, and you can see it's in the form of oops, this is not what I'm looking for. Yeah, so this is a version number. So this is the jar file. Okay, and the same deal with the local repository. So this is a Maven Central. Okay. And so we just did this one. Plugins and goals. So Maven is based on plugin architecture, as I said before. So all Maven tasks are performed through plugins. So as we learned before, each phase is actually being executed through the goals of some plugins. Okay. The plugin is downloaded, and then plugin is going to run the task. So Maven command itself, initially, when you are actually running Maven the first time, Maven command is just a shell, and then it will actually download everything that it needs and then install it into your local repository. So it parses a pom.xml file and figures out which plugins are needed and then download them. So the first time you're running Maven, you might actually see some downloading. After that, it's going to actually look for the files in the local repository, so it doesn't have to download them again. Okay, so plugins are downloaded like dependencies are downloaded from remote repositories as needed basis, and then it will be maintained in the local repository. Okay. Plugin is just like any other thing, is a Maven project, so it should have its own identity, meaning it should have a group ID, artifact ID, and version number. And downloaded plugin is then maintained in the local repository. So what is a plugin? Plugin is a collection of one or more goals. You can think of these goals as tasks. Okay. So examples of ready-to-use plugins, archetype plugins. So when you say Maven archetype :generate, basically we are using archetype plugin. Okay, and the generate is a goal. One of the goals archetype plugin support. Job plugin has goals for creating job files. Compiler plugin contain goals for compiling source code and unit test. And the Hibernate 3 plugin should have goals for integration with the Hibernate library. JRuby plugin should have goals executing JRuby as part of the Maven build. You can certainly create your own custom plugin, and this custom plugin can be written in many different languages. Now, the benefits of this plugin architecture. So common plugin is used by everyone to every project. So everybody's using the same compiler plugin. So the behavior of that plugin is going to be the same, regardless of what project a person is working on. So everyone understands what plugin does. No need to relearn. So there is no learning curve involved. Plugin can evolve and improve without breaking other parts of the build, because plugin is just another Maven project, so it has its version number. So based on version number, it can evolve and without breaking the backward compatibility of your application. So change and improve in a plugin benefit everyone. So the plugin vendors might actually improve their plugin with a new version number. So if you want to actually build your application using old the plugin, you just specify old version number. If you want to take advantage of new version, then you just specify new version number. Okay, so what is a goal? Goal is a unit of task. Again, you can think of it as task, and in end, it is actually called a target, right? So you can think of it as the same thing as a target in end. So example goals: generate goal of archetype plugin. So that's what we have done as a first exercise, right? Maven archetype :generate. That means I'm using archetype plugin and then performing generate goal. Okay. Compile goal of compiler plugin, and test goal of Surefire plugin. Plugins can be configured. So if I want to use a Maven compiler plugin, and if I want to use JDK 1.6, then I can actually specify the configuration. Okay. So if you want to actually find the Maven compiler plugin, you can go to your local repository, and there should be org directory. Underneath, you should have Apache directory. Underneath, you should have a Maven directory. And then underneath, you should have a plugins directory. Okay. And then there should be the artifact of, there should be Maven compiler.plugin job file. Okay. Make executable job plugin. So this is an example of the plugin that you can use. You can actually create a job file that contains the main class in its meta the data, right? So that you can actually just run the job rather than actually specifying the main class, right? So you can actually use Maven job plugin, and then you have to specify the main class. Okay, so this is the main class that contains a main method. Okay, and then you can actually run the job file as an executable job. So this is an example of a job, the example of the plugin that you can use. Okay, so that is exercise 2. Here in exercise 2, we are going to in fact create executable jar, using this plugin. Okay. All right, so let's take a look at the exercise 2. So, when you run Maven clean, it will delete everything on the target directory. Okay, and then you can say Maven -x compile, and then it might actually, show you more detailed information, and you can see it's using 1.5 as a default. Okay, now if you want to use 1.6, okay, JDK, then you can specify the configuration for this Maven compile plugin. Okay, so you don't have to specify this one unless you want to change the behavior, in this case using a different version number. Okay, so if you want to use a version number 1.7, then you have to actually specify this configuration for that plugin. So the only time that you want to actually add this plugin as in here is when you're actually deviating from the default. Okay, now when you run it, then it should use 1.6. Okay. Now we are going to use Maven jar plugin. So this is the plugin that we can use to create a jar file that contains the main class as part of its as part of the meta information in the jar file. Okay, so we are using Maven jar plugin, and this is a configuration. And in this configuration, I'm actually specifying the main class. Okay, so this main class has to be reflecting whatever information that you specify, whatever the project that you have. Okay, this is probably not correct. This one's supposed to be this one should be dot, whatever main class that you have is gonna be the hello world dot it's gonna be org.javapassion.com, the examples dot app. Okay, so that should be the so this is probably not the this is something that you have to change. Okay, then you actually run the Maven package. Okay, then it will create a jar file, right? And then you can run the executable jar file. So instead of actually specifying the main class, you can just specify the -jar, -jar, and jar file. Then it will run the code. Okay. And you can take a look at your local repository, all the plugins that are already downloaded and installed. Okay, you can see it has actually downloaded Maven jar plugin after this. Okay, all right. I'm gonna give you guys about 10 minutes to try this, and let's have 15 minutes break. So we will be back at 55 after the hour. Okay. Okay, so let's get started. So the next topic is the dependency management. So dependency is like a jar file that you need in your application, and each dependency is specified using dependency coordinates, meaning dependency identity. So dependency is a project, so it should have its own identity in the form of group ID, artifact ID, and version number. Again, this is something that you have seen already, right? Transitive dependencies. So Maven is intelligent enough to figure things out, to figure the dependencies that are needed by your application. So let's say usage scenario is like this. Your project has a dependency on library A, and library has its own dependencies to B, C, D, E, and F. Your project needs to specify dependency only on A, and then Maven will figure that it will need this B, C, D, E, F, and it will download all of those dependencies and install them in your local repository. Okay? And Maven can even actually handle conflict between dependencies. Okay? What it means is that suppose if you're using library B and library C, and library C has a dependency on D version 4, and library C has a dependency on D on version 6 or something like that, then it will figure, I'm going to actually use the latest version of the D, even though C says it wants a version 5 or something like that. Okay. You can check the dependency tree through Maven command. So Maven dependency tree. So if you run this command, you are going to see all the dependencies. Okay, so this is an example. So it's a Spring MVC application. So it will give you the directory structure of all the dependencies. So it needs to have a dependency of, for example, ORG Spring Framework, Spring Context, and Spring Context has a dependency of this. And this one has its own dependencies, right? So this one actually shows you all the dependencies that are needed by your application. However, you specify only the top level dependency in your pom.xml file. Okay, so dependency scope. Scope basically specifies when it's going to be used. So when you say scope test, this JUnit is going to be used only in test scope, meaning it's not going to be used in it's not going to be used in, for example, like execution time and things like that. Okay. Let me see whether people are experiencing. I want to actually finish this one. So Maven support in IDEs. So each IDE has its own. Well, the Maven support is actually pretty important for us developers. The reason is because without using Maven as a project type, if you're using Eclipse project is not really portable to NetBeans or IntelliJ. So every developer has his or her own favorite IDE, and they could not really exchange the projects because each IDE has its own proprietary project metadata. So it results in IDE lock-in. Once you start using Eclipse, you cannot use the projects that you created using Eclipse in IntelliJ or vice versa. Okay, but Maven actually standardized the project metadata, so developer can use whatever IDE of his or her choice on any Maven project. So if you create a Maven project at the command line or using Eclipse, you should be able to actually import it and use it, build it in another IDE of your choice. Okay, so all major IDEs support Maven. Okay, so create Maven project and import the Maven project, and then so they actually they might actually also provide an extra features like a form-based POM editor, so graphical representation of the POM editor and things like that, which is not a big deal. Okay, the key point is that now we developers are freed from IDE lock-in as long as we all use a Maven. Okay, and I can use any IDE of my choice as long as the projects are in the form of Maven. Okay, it also actually has a tight integration with other IDE build tools like a version management and task management and things like that. I think one of the questions was, what is the relationship between Maven with version management systems such as SVN and Git and things like that. It works very, very well with those version management tools. Okay, so exercise 5 is import Maven project into Eclipse. We have already done this one, so I'm going to just move forward. Maven web project structure. So when the project we just created using a default, archetype was a very simple Java application. Now we are going to actually build Maven web project, and then the Maven project should have another directory called src main web app. So this is the directory that contains all the web application specific files, for example, web.xml file, the JSP pages and things like that. So this is something that you are going to actually see when you're actually using an archetype for creating a web project. Okay. So create a simple Maven web project using Eclipse. I'm going to actually describe this process, this exercise, and then we're going to actually move forward. Okay. Now, the last item that I'd like to talk about in this presentation is comparison of Maven to Ant. Okay. So in order to actually build a very simple application of what you just built, this is what you have to write. You have to write how many lines of code? Almost like 30 or 40 lines of the code. Okay, so if you compare Maven and against Ant, so this is Ant. Ant doesn't have a formal conventions like a common project directory structure or default behavior. Meaning, anybody who's actually using Ant has to come up with his or her own directory structure, and they could be all different, right? So you have, and then you have to tell Ant exactly where to find sources and where to put the output. Okay. It's procedural. We have to tell Ant exactly what to do and when to do it, and you have to tell it to compile, then copy, and then compress. So these sequence of things need to be specified in precise order. Otherwise, it's not going to work. Okay. it doesn't have a life cycle. You have to define task and task dependencies. Again, everything has to be specified in detail and precisely in Ant. Otherwise, even if you make a very small mistake, it's not going to work. So that's Ant. In Maven, this is what you say. So you say, I just want to create the project in the form of default job file or something like that. Okay. So Maven, it has a convention. So it knows where your source file is because it follows the conventions. Okay. So Maven compiler plugin puts the bytecode and target classes. So it produces a job file in target. So it uses the conventions. So 99% of the time you are going to in fact actually use these conventions. It's declarative. All you have to do is to create a pom.xml file and put your source in the default directory, and then Maven takes care of everything else. Okay. It has a lifecycle which gets invoked when you execute the Maven install. So when you say Maven install, then it will do everything, including testing. Okay, so it tells Maven to execute a series of sequential lifecycle phases until it reaches the install lifecycle phase. So you don't have to actually specify all those detailed tasks as you have to do in Ant. Okay. So as a side effect of this journey through the lifecycle, Maven executes a number of default plugin calls, which did things like a compile and create a job file and doing the testing and things like that. So you can see Maven actually simplifies a lot of build headaches. Okay. All right. So let's actually take a look at the exercise. So import existing Maven project to Eclipse. We have already done that. And generating Maven web project using Eclipse is very simple. You say new, other, and Maven project. And here you can specify, you can select the archetype. Okay. So if you want to actually create a web app, you can just filter. If you type web app, and then we are going to choose this archetype. Okay. This archetype, Maven archetype web app. Okay. And then you provide the group ID, artifact ID, and version and the package. Okay. And then it will create the directory structure with web.xml file and index.jsp file. Okay. So now, you should be able to run this application. Okay. And we are going to actually modify the project. So we are going to actually modify the index.jsp page with hello.jpassion.com. And then save the change. And when you run the application, then you should be able to see the result. Okay. And if you want to add a servlet, you can add build path. So as a default, this archetype does not create a Java directory. Okay. So it does create a web app directory, but it does not create the src main Java directory. So we have to create a src main Java directory. So here, build path and new source folder. So we are going to create the src main Java. And then that directory is created, and underneath we are going to create a servlet. So we're going to create the new servlet, and the name of the servlet is my servlet, and this is the Java package. And then we are, then it actually creates the servlet template. Okay, and you probably see a bunch of compilers at this point. Okay. So you can actually modify that IDE generated, Maven generated my servlet.java file with this code. We just want to actually display something. Okay, all right, like this. And then we are going to, it also create a web.xml file. Okay, and here we are going to add servlet dependency. The reason you are experiencing compilers is because we have not included the servlet dependency. So we're going to actually add servlet dependency with this, and you can see this is actually provided because we do not want to have this one to be in the WAR file when we are deploying this application, right? So this is used only for compile purpose. Okay, and then when you save it, then the compile errors should be gone. Okay, and you can also actually run this application on any apps of your choice, and Jetty is actually popular the server, so you can actually add the Jetty plugin. Okay, and you save the change, and then you should be able to run the application. So perform Maven package first of all, create the WAR file, and then at the command line you can actually go to Maven Jetty run. Then it's going to run that application on Jetty. Okay, and then you can go to this URI, and then you should be able to see servlet being executed. Okay, and you can run the application over Tomcat as well. So you can say select it and run on server, and you can select the Tomcat or the BC server, whatever server of your choice. Okay, you can create a web project at the command line. So here you can specify artifact ID and the group ID and all those things at the command line. So you say Maven archetype generate, and the group ID is this, and artifact ID is this, and artifact archetype ID is this. Okay, and then the interaction mode false. Okay, so basically it does create everything. So this shows how you can create the project at the command line without actually going through the interactive mode. So this you specify things as an options as an options to archetype generate command. Okay. All right. So I'm going to stop right here.